temperature rating of electrical tape depends on its type and application. General-purpose vinyl electrical tape is typically rated for temperatures up to 80 degrees Celsius, which is 176 degrees Fahrenheit. High-temperature electrical tape, such as fiberglass tape, can be rated for temperatures up to 105 degrees Celsius, which is 221 degrees Fahrenheit, or even higher. The Canadian Standards Association, or CSA, provides approvals for electrical products, including electrical tape. CSA standards for electrical tape specify a temperature rating of 105 degrees Celsius. Underwriters Laboratories, or UL, is another organization that provides safety certifications. UL standards for electrical tape generally specify a temperature rating of 80 degrees Celsius. In the United States, the National Electrical Code, or NIC, specifies the use of electrical tape with a temperature rating of at least 80 degrees Celsius for most applications. This includes covering wire nuts. Weenie wire nuts are small wire nuts used to connect multiple wires within a luminaire. They are typically not suitable for temperatures above 80 degrees Celsius. It is not always necessary to cover wire nuts within a luminaire with electrical tape. You only need to do so if the luminaire is rated for temperatures above 80 degrees Celsius. Electrical tape in the United States is generally rated for temperatures up to 80 degrees Celsius. Covering wire nuts in luminaires with electrical tape is not necessary unless the luminaire is rated for temperatures above 80 degrees Celsius. For applications that require 90 degrees Celsius conductors, it is more important to use the appropriate tape, for example, fiberglass tape, than to cover the wire nuts with standard electrical tape. It's important to understand these temperature ratings and application guidelines to ensure safe and code-compliant electrical installations. When selecting electrical tape, verify the temperature rating and ensure it is suitable for the intended use. If the application involves high-temperature environments, opt for a high-temperature tape specifically designed for such conditions. Always refer to the manufacturer's specifications and local electrical codes for specific requirements. The NEC provides guidelines on conductor insulation temperature ratings and allowable ampacities based on these ratings. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to 90 degrees Celsius in free air and in raceways. The temperature rating of the conductor must be suitable for the termination temperature rating of the connected equipment. For instance, if a luminaire requires 90 degrees Celsius conductors, ensure that the wire connectors and any tape used are also rated for 90 degrees Celsius. The common practice of using electrical tape to cover wire nuts is often done for added protection and insulation. However, it is not always required by code, especially if the wire nuts are properly installed and rated for the application's temperature. In situations where the luminaire operates at temperatures exceeding 80 degrees Celsius, high-temperature tape is preferable to ensure the tape does not degrade or lose its insulating properties over time. Choosing the correct wire nut size is crucial for a safe and reliable connection. Overfilling a wire nut or using a wire nut that is too small can lead to loose connections, overheating, and potential fire hazards. The wire nut manufacturer provides guidelines on the number and size of conductors that can be safely accommodated within each wire nut model. Always follow these guidelines to ensure a secure and compliant connection. When dealing with multiple small gauge wires, such as 18 American wire gauge or AUG wires in a luminaire, it is essential to use a wire nut that is specifically designed for such applications. These wire nuts typically have a wider opening and deeper threads to accommodate the multiple conductors. Alternatively, consider using a different type of connector, such as a push-in connector, that is rated for the number and gauge of wires being connected. Push-in connectors offer a quick and easy way to make secure connections without the need for twisting the wires together. Always ensure that the connector is UL listed and rated for the intended application. When installing wire nuts, it is important to strip the insulation from the wires to the correct length. Too much exposed wire can create a shock hazard, while too little exposed wire can result in a weak connection. Use a wire stripper to remove the insulation without nicking or damaging the conductors. After stripping the wires, twist them together in a clockwise direction before screwing on the wire nut. This ensures a tight and secure connection. Once the wire nut is installed, gently tug on each wire to verify that it is securely held in place. If any wires come loose, remove the wire nut and repeat the process, ensuring that the wires are properly twisted together before installing the wire nut. In some cases, it may be necessary to pre-twist the wires before installing the wire nut. This is especially important when dealing with stranded wires, which can sometimes fray or separate when twisted together by the wire nut alone. Use pliers to twist the wires together tightly before screwing on the wire nut. This creates a more secure and reliable connection. When working with aluminum conductors, it is essential to use wire nuts that are specifically designed for aluminum to copper connections. These wire nuts are filled with an antioxidant compound that prevents corrosion and ensures a reliable connection between the dissimilar metals. Using standard wire nuts for aluminum to copper connections can lead to corrosion, overheating, and potential fire hazards. Always check the wire nut packaging to ensure that it is suitable for the intended application. In addition to temperature ratings, electrical tape also has voltage ratings. The voltage rating indicates the maximum voltage that the tape can safely insulate. For most general-purpose applications, electrical tape with a voltage rating of 600 volts is sufficient. However, in high-voltage applications, it is essential to use tape with a higher voltage rating. Always check the voltage rating of the tape and ensure that it is suitable for the intended application. Electrical tape is also available in a variety of colors. Each color has a specific meaning and is used to identify different types of circuits. For example, black tape is typically used to insulate and protect electrical splices, while white tape is used to mark neutral conductors. Green tape is used to ground conductors, and blue tape is used to identify isolated conductors. Using the correct color of tape can help to prevent confusion and ensure safe electrical installations. When applying electrical tape, it is important to overlap each layer by at least 50%. This creates a watertight seal and ensures that the splice is properly insulated. Start by wrapping the tape around the wire a few inches from the end of the splice, and then continue wrapping the tape in a spiral pattern, overlapping each layer by at least 50%. Once you reach the end of the splice, continue wrapping the tape back over itself, again overlapping each layer by at least 50%. Finally, press the tape firmly into place to ensure a secure and watertight seal. In addition to electrical tape, there are a variety of other types of insulating materials that can be used to protect electrical splices and connections. Heat shrink tubing is a popular alternative to electrical tape. Heat shrink tubing is a plastic tube that shrinks when heated, creating a tight and secure seal around the splice. Heat shrink tubing is available in a variety of sizes and materials, and it can be used to insulate splices in a wide range of applications. To install heat shrink tubing, simply slide the tubing over the splice and then heat it with a heat gun. The tubing will shrink and conform to the shape of the splice, creating a watertight seal. Another option for insulating electrical splices is to use a liquid electrical tape. Liquid electrical tape is a paintable coating that provides a protective and insulating layer over the splice. Liquid electrical tape is easy to apply and it dries quickly, forming a durable and watertight seal. Liquid electrical tape is available in a variety of colors, and it can be used to insulate splices in a wide range of applications. When working with electrical splices, it is important to always disconnect the power before beginning any work. This will help to prevent electrical shock and ensure your safety. Use a voltage tester to verify that the power is off before touching any wires or connections. If you are not comfortable working with electricity, it is best to call a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety. In addition to temperature ratings, voltage ratings, and color codes, electrical tape also has a variety of other properties that can affect its performance. These properties include adhesion, tensile strength, elongation, and dielectric strength. Adhesion refers to the tape's ability to stick to a surface. Tensile strength refers to the tape's ability to resist tearing. Elongation refers to the tape's ability to stretch. Dielectric strength refers to the tape's ability to insulate against electricity. When selecting electrical tape, it is important to consider all of these properties to ensure that the tape is suitable for the intended application. For example, in applications where the tape will be exposed to moisture or chemicals, it is important to select a tape with good adhesion and chemical resistance. In applications where the tape will be subjected to stress or tension, it is important to select a tape with high tensile strength and elongation. And in applications where the tape will be used to insulate high voltage circuits, it is important to select a tape with high dielectric strength. In addition to using the correct type of electrical tape, it is also important to use the correct tools and techniques when applying the tape. Use a sharp knife or scissors to cut the tape to the desired length. Avoid stretching the tape too much, as this can weaken the adhesive and reduce its effectiveness. Apply the tape smoothly and evenly, overlapping each layer by at least 50%. Press the tape firmly into place to ensure a secure and watertight seal. Following these tips will help you to ensure that your electrical splices are properly insulated and protected. In summary, electrical tape is a versatile and essential tool for any electrician or dyer. However, it is important to understand the different types of electrical tape and their properties in order to select the right tape for the job. By following the tips outlined in this guide, you can ensure that your electrical splices are properly insulated and protected, and that your electrical installations are safe and compliant with local codes. Always remember to disconnect the power before working on any electrical circuits, and to call a qualified electrician if you are not comfortable working with electricity. Electrical safety is paramount, and it is important to take all necessary precautions to protect yourself and others from harm. Understanding the National Electrical Code, specifically Article 310.10a, which covers conductor insulation, is vital. This section dictates that conductors must be insulated and suitable for the voltage, circuit conditions, and location. The insulation type must be listed and marked on the cable or conductor. These markings typically include letters indicating the insulation material and temperature rating. For example, THHN is a common type of building wire with a thermoplastic high heat-resistant nylon jacket. It is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THWN is another common type of building wire with a thermoplastic heat and water-resistant nylon jacket. It is rated for 75 degrees Celsius in both wet and dry locations. The NEC also provides tables listing the allowable ampacities of conductors based on their insulation type and temperature rating. These tables are essential for selecting the correct size conductor for a given circuit. When working with luminaires, it is important to pay attention to the luminaires markings and instructions. The luminaire will typically indicate the type and size of conductors that are required. It will also indicate the maximum operating temperature of the luminaire. This information is essential for selecting the correct type of electrical tape and wire connectors. In some cases, the luminaire may require the use of high-temperature conductors and connectors. These components are designed to withstand the high operating temperatures of the luminaire. Using standard components in a high-temperature luminaire can lead to premature failure and potential fire hazards. Therefore, it is essential to use the correct components when working with luminaires. When making wire connections in a luminaire, it is important to use the correct size and type of wire connector. Wire connectors are available in a variety of sizes and materials. The size of the wire connector must be appropriate for the size and number of conductors being connected. The type of wire connector must be appropriate for the type of conductors being connected. For example, when connecting aluminum conductors to copper conductors, it is important to use a wire connector that is specifically designed for this purpose. These connectors are filled with an antioxidant compound that prevents corrosion and ensures a reliable connection. Using standard wire connectors for aluminum to copper connections can lead to corrosion, overheating, and potential fire hazards. Therefore, it is essential to use the correct wire connectors when making wire connections. In addition to wire connectors, it is also important to use the correct tools and techniques when making wire connections. Use a wire stripper to remove the insulation from the wires. Avoid nicking or damaging the conductors. Twist the wires together tightly before installing the wire connector. This will help to ensure a secure and reliable connection. Once the wire connector is installed, gently tug on each wire to verify that it is securely held in place. If any wires come loose, remove the wire connector and repeat the process. Following these tips will help you to ensure that your wire connections are safe and reliable. When working with electrical circuits, it is important to always follow the NEC and local electrical codes. These codes provide guidelines on the safe and proper installation of electrical systems. By following these codes, you can help to prevent electrical shock, fire hazards, and other potential safety problems. If you are not comfortable working with electricity, it is best to call a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety. Remember to always prioritize safety when working with electricity. Disconnect the power before working on any electrical circuits. Use the correct tools and techniques. Follow the NEC and local electrical codes. And call a qualified electrician if you are not comfortable working with electricity. By following these guidelines, you can help to ensure that your electrical installations are safe and reliable.